Howdy all, and welcome to another installment of our MLOs to help you understand the material in Math 2201. So we've already introduced quadratics, and now we're going to do some practice type questions with those, focusing on those same 4 key points that we saw in our last installment. Equation of a quadratic, the simplest quadratic, and mostly we're going to look at parabolas and their graphs and the properties of those parabolas. Okay? So here's our first question, and it's a multiple choice type thing. It says, which is the graph of a quadratic function? Now, this is not a hard question. And if you get this one on a test, you should be very happy. First of all, there's 2 of these that we're going to sort of cut out of the mix altogether, and one of them is going to be this guy over here. No way is that right. And the other one is going to be this one. So B and D are out of the thing. And the reason is, those are straight lines, and you should recognize from grade 10 that when you have a straight line, both of these are linear functions. Okay, now we have to get to be a little bit subtle here, and this question might not be a perfect question because of the subtlety we're going to look at for A and C, but we'll see. So, which one of these things that we have here looks like the graph of a quadratic function? Well, they both kind of do, but one of them looks a little better than the other, and this C business is out. These are both parabolas, but for the quadratic functions that we study, and for a true quadratic function, parabolas open either upward or downward. They don't open sideways. This one over here, this graph, is actually an irrational or a radical function. Wow, that's crazy. And you're going to see a little bit of that stuff, or you saw a little bit in an earlier unit in this course, I would think, although we didn't spend a lot of time talking about graphs of radical functions. But even though this is a parabola, it's not really the graph of a quadratic function unless it opens strictly up or down. Okay, so you got to be careful about that. That's the one sort of hiccup you can get with a question like this. So A is our only correct answer. All right, so we move along now. The second question says, for this parabola, we have to determine the vertex, the axis of symmetry, and the direction of opening. Okay, another pretty straightforward question. We haven't got a lot of material covered yet to do anything terribly difficult, but we can sort of learn a little bit about these things and go as we like. So first of all, the vertex. You have to remember the vertex is the point that's either at the very top or the very bottom of your graph of your parabola. And in this case, it's right down here at the very bottom. And so the vertex is, it's either, we sometimes call it a maximum or a minimum value on the graph. In this case, it's a minimum because it's at the bottom. But when they say determine the vertex, what we really want to know are what are its coordinates. Okay, so it has an x and a y coordinate. It's 4 units to the right of the origin, so its x coordinate is 4, and it's 2 units down, so its y coordinate is 2. So let's write out an answer for this as we'd expect to see it. So the vertex here is going to have coordinates of 4 and -2. Okay, the next thing we want is the axis of symmetry. Okay, so the axis of symmetry, if you remember from our other video, is like a line of symmetry that cuts the parabola into 2 identical halves. And it always runs vertically like that. And now the axis of symmetry, I sometimes abbreviate that as the AOS. Hopefully you'll know what I'm talking about. The axis of symmetry is that vertical line, but we don't just say draw it, and we don't just say, okay, look, we see it's right here, it's at 4. Axis of symmetry is always represented by an equation. So the equation for the axis of symmetry is always x equals, because everywhere on that line, x is the same number. So we say x equals 4. Vertical lines have an equation of x equals some number. So make sure and be very specific about that. Okay. So it's always an equation, x equals 4. And then the last thing we have to find for this graph is the direction of opening, and that's very simple. So the graph either opens upward or it opens downward. So if your vertex is on the bottom, you go up from there, you're opening up. So the opening on this parabola is up here at the top. So that's easy. So we just say it opens up, or if you want to say upward, that's fine. So it opens upward, okay? And that's about it for those questions. Those are pretty simple questions to get started, but things will get a little more complicated as we go through this, I promise. Okay, don't mean to insult anybody's intelligence. So remember, we're looking at quadratics, which are polynomial functions of degree 2, and they're all transformations of that basic parabola, okay? And the values of A, B, and C create different parabolas. And we're looking at the axis of symmetry, which is a vertical line and it has to have an equation, the direction of opening, which is up or down, and the vertex, which is that one lonely point at the very top or the very bottom. Hopefully that's helpful. See you in the next installment.